Hello, everybody. Good afternoon. Thank you. Thank you for having me as a speaker today. My name is Marian Valera. I am an embryologist and clinical researcher in IVIRMA Valencia right now. And part of my research is focused on optimizing and controlling the factors that surround the embryos during in vitro culture. So today I'm going to talk about a study that we performed last year and we published in Human Reproduction, which is about culturing embryos in high humidity conditions. One of the key factors to achieving a successful IVF treatment is to control and to optimize all the factors that conform the environment of the embryo during in vitro culture. And this, of course, includes the culture media, with its composition, osmolality, etc., the lab environment, it's important to control the quality of the air, the light exposure, and, of course, the conditions inside the incubator, like the temperature, the gas mixture, and finally, the factor that I'm going to talk about today, which is the humidity content. Nowadays, the standard in most IVF laboratories is to use incubators that work in dry conditions. And this is because, well, we have evolved from the big box humidified incubators until smaller ones that has been especially designed for embryo culture and work in dry conditions, as I said, because it brings many advantages, such as better control of the conditions, also a faster recovery rate after every door opening, and it also helps avoiding fungal contamination. However, dry culture is not perfect either. It also has disadvantages, being the most important one, it facilitates the evaporation of the culture media, leading to an increase in the osmolality that has been demonstrated to be detrimental for the embryos in many ways. It has been demonstrated to increase the developmental arrest rate, also changes in the gene expression, genetic alterations, and overall worse clinical outcomes in IVF treatments. But humid culture has been reintroduced for embryo culture with this incubator, which is the Geri. This incubator has 6 independent chambers, 1 per patient, and the conditions of each chamber are controlled independently. And it also brings a water adapter that you can connect to the chambers that you select, and it directly humidifies the gas influx, achieving around 60% of relative humidity inside the chambers that you select. Also, this incubator has more time-lapse technology, which allows us to evaluate the embryos remotely through the platform Geri Connect, and it also allows us to know the kinetics of the embryo development through the automatic annotations performed by the SS 2.0 software. So we in our EV clinics have several Geri incubators, so we decided to design a retrospective study comparing the embryo development and the clinical outcomes of the embryos that were cultured in dry or humid conditions. So in order to do that, we set all the Geri incubators the same way, with 3 chambers working in dry conditions and 3 with the humidifying adapter, while the rest of the culture conditions remain exactly the same for the whole 6 chambers. In total, we included 1,627 ICSI cycles and over 1,600 embryo transfers, all performed in 3 EV clinics over a period of 3 years, and including the 3 main types of treatments performed in our laboratories, which is ICSI treatments with autologous oocytes, also autologous ICSI but with genetic testing for aneuploids, and ICSI treatments with donated oocytes. The rest of the culture conditions were the standard that we use in the laboratories nowadays, which is long culture until blastocyst stage, using GEM single-step medium with no refreshing for the whole culture, and of course using the Geri dish, which is specific for this incubator, that has room for 16 embryos that share 1 drop of culture media, covered by a thick layer of, in this case, light mineral oil. In order to compare the the clinical outcomes, we perform an advanced statistical analysis consisting on weighting each cycle in base of all these characteristics. So we created like a pseudo population where all these possible confounders were balanced. So this way we could have a more robust inference of the outcomes. So starting with the results of our study, first we focused on the parameters of embryo development, and we did not find any statistically significant differences in the blastocyst rates at day 5 or the proportion of the blastocysts with a good morphology classification in any type of cycle. They were more or less the same. And we didn't find any differences also in the biopsy rates in PGTA cycles. When we studied the morphokinetics of the embryo development, we did find differences. We found that the embryo cohorts cultured in humid conditions had an overall faster development, with statistically significant differences in 4 morphokinetic parameters, being the most relevant one the time to reach the motile stage, which faster times have been previously related with higher embryo quality and higher implantation potential as well. When looking at the clinical outcomes, here in this forest plot, we represented the odds ratio. It's like the comparison of the probability of the embryos of achieving these outcomes when cultured in humid versus dry. And we saw a significant value for the clinical pregnancy. This value over here means that embryos cultured in humid conditions were 1.236 times more likely to achieve a clinical pregnancy when cultured in humid conditions. And looking at the rest of the outcomes, we also can see a positive trend, but it was not strong enough to be statistically significant. Then we stratified the results by type of treatment, and it was interesting that we found a very strong association with the clinical pregnancy in PGTA cycles, where all these embryos, although all of them were analyzed as epoid, had 1.7 times more chances to achieving this clinical pregnancy when they were cultured in the humidified chambers. And this translated in an increase of 12% in the raw clinical pregnancy rates in our PGTA cycles of this period of time. 12%, which is very considerable. And we also had a look at the cumulative pregnancy cohorts, and we also saw a more positive trend with the embryos cultured in humid conditions in autologous and PGTA cycles. So, of course, we made the question of why it seems that humid culture seems so favorable in PGTA cycles. So we hypothesized that the embryos belonging to these type of treatments are subjected to more stress than the other embryos. And this coming for 2 main sources, one being the oocyte age, as this technique is applied to older patients, and also because of the procedure, which is more invasive per se, because we had to do the assisted hatching and then the biopsy. So it seems that culturing embryos in a less stressing environment helps decreasing the impact of this already compromised situation in the area. So the conclusions of the study were that using this particular culture system, which is based in the undisturbance of the embryos for a very long time, using integrated time-lapse system and single-step culture medium, culturing the embryos in higher relative humidity conditions increases the likelihood of achieving a clinical pregnancy. So this seems to be a valid approach to further optimize this cultural strategy, and it seems to be especially suitable for treatments with compromised embryo quality. So now it's time to implement the improvement, and we already did. As in our laboratory, we switched all the Geri incubators to only the humid setting, and we are currently working only with humid conditions. Thank you so much for your attention, and if you have any questions, you can look for me around in the Congress.